Here we go. Any questions on any of the homework? I guess I should put this back on that side since I stand over there, don't I? Any of those that, could you not see maybe a couple of them? Got those, right? So 16 maybe missing? Get 16 right? Was this the one that you, what was the one you had to add 5%? Was that 17?
Yeah.
Okay. All right, so for 17, let's go over that one. It says, we gave you a table of 3 numbers: private school, college, in-state public school, and out-of-state. And that was back in 2004. It says costs are expected to increase 5% per year. Use a scalar product to find the estimated cost for each type of college in 2005, so a year later. So what I do in a problem like that, percent, I think we've done a few percent problems, haven't we? Maybe it wasn't this class, maybe it was my CP class. But our numbers, our little matrix, were 27,677. And I'm going to need to have more room here, aren't I? Do this. And then 12,841. What's the address of that, Sydney?
1, 2.
1, 2, very good. You guys all knew that, right? And then 19,188. Okay, so 5% increase. Right, increase is added on, right? What some of you probably did, or most of you, took 0.05 times each number and then added it to the number, didn't you? Is that how most of you did it? 0.05 times those, and then added that answer to those original numbers, right? For the increase. All right, what I like to do is add or subtract increase or decrease from 100%. All right, so if I add 5% to 100%, how many percent is that? 105%. And then I multiply that number by the numbers. So I would have done 1.05 times all of those. And I wouldn't have, so I do the addition beforehand. That's all. If it was a decrease, I'd make it 0.95. Subtract 5% from 100. Okay? So my scalar is 1.05. Okay? And then you'll get the 3 numbers. Let's go to our calculator. You'll want to have your calculator out today. We're going to use it. All right, so 1.05 times 27677. That's 2960. Did it say to the nearest dollar or anything? I think it did, to the nearest dollar. So 29,061. All right, that would be that one. Then 1.05 times, I'll show you something. If I hit second enter, it gives me the last problem I put in there, and you could just put new numbers if you want. 12841. So 13,483. And then second enter, and then go back and do 19,188 and 20,147. So that's how I would do that problem. Just a different way. What you did is not wrong. Okay, but sometimes I think that's quicker because you can do the addition 5, 10%, in your head, right? And then you just have to change it to a decimal, all right? 105% is 1.05, right?
Yes.
All right, any others you have a question on? All right, cool. All right, yesterday we added and subtracted the matrices, right? We had to have the same dimensions. What do we name first? What are these things called? Rows, and then columns, right? Rows by columns. All right, they have to be the same dimensions to add and subtract. And do the scalar, it doesn't matter. Whatever dimensions are, just multiplying numbers, kind of like the derivative problem, right? All right, well, today we're going to multiply matrices. Okay? So, matrix product, again, product means multiply. Square matrix just means the dimensions are the same, 2 by 2, 3 by 3, so and so. Main diagonal, multiplicative identity matrix. What was the additive identity matrix yesterday? What numbers were in it? Additive identity matrix. If I add a matrix to another matrix and get the same matrix back, what were all the numbers in the other matrix? All zeros, remember?
Yes.
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 Okay. So, again, you won't get quizzed on that though, but it's just all good. Multiplicative identity matrix, they're all ones along the main diagonal. Everything else is zeros. We'll go over that here in a few minutes. All right, in lesson 4.1 yesterday, you multiplied matrices by a number called a scalar. You can also multiply matrices together. The product of two or more matrices is the matrix product. The following rules apply when multiplying matrices. All right, so here's the rules. Matrices A and B can be multiplied only if the number of columns in matrix A equals the number of rows in B. Number of columns in the first matrix is equal to the number of rows in the second matrix. That number has to be the same. The product of a M by N and N by P, see this number of columns of the first one must be equal to the number of rows of the second one. So that number is the same. The size or dimensions of the product, the answer, would be the number of rows of the first one by the number of columns of the second one. Okay? So, columns of the first one must be equal to the number of rows of the second one. The size of our answer will be the number of rows of the first one by the number of columns of the second one. Okay, so A times B, we can do that. This is a 2 by 3, and this is a 3 by 4. Since these are equal, like it says here, I can actually multiply those two. All right, the size is 2 by 4. Well, I'm done. Okay? C times D we can't do. C's a 3 by 2, D's a 3 by 5. The 2's and the 3 aren't the same, right? So you could not multiply matrix C times matrix D. Because the number of columns of C does not match the number of rows of D. Okay? That's what you look at first to see if you can do it or not. Okay, now pay attention. All right? All right, won't start if you don't work, if you don't have that. All right, so W times X, is it possible? What's the dimensions of W? 3, 2. What's the dimensions of X? 2, 3. Can I multiply them? Yes. Those are equal, right? Okay, so here's how you do it. They're not gonna show us how to do it, they're gonna make me do it. Let's go back, I'll show you how to do it. All right. I thought maybe they'd show us on the next slide. All right, so here's what you think about. Rows by column. All right? So what's the size of WX going to be when I'm done? 3 by 3. That's the size it's going to be, which is a square matrix, by the way. They're the same. That says right there, too, doesn't it? All right. So anyway, I want to try to. It's kind of hard to show all this at once. Okay. So here's the spot A, WX 11. Right. Its address is 11. Right. So you go 3 times 4 plus -2 times 5. Whatever answer that is the number that goes there. Okay? Then it's 3 times 7 plus -2 times 1. And then it's 3 times what? -2 plus -2 times what? -1. So you're going across and then down. Okay? Now I do the same thing for this middle one, but what numbers do I use in the 3 and -2 spot?
1 and 0.
1 and 0, right. So it's 1, that's still 4, plus 0, that's still 5. 1, that's still 7, plus 0, 1. 1, -2, plus 0, -1. So this time you're going, first, you're going through that, and then these two, down, down, down. Okay? And then the bottom row is going to be what in the 1, 0 spot? 2, -1. I'm just getting, those are the same each time. You guys see that?
Yeah.
So there's my 9 numbers once I find those answers. So it would be 12 minus 10, 21 minus 2, -6 plus 2. I gotta make it a little bigger, I think. You okay with the top row? 4 times 0, or plus 0, sorry. 7 plus 0, -2 plus 0. 8 minus 5, 14 minus 1, -4 plus 1. Questions? You follow that? Can we go to the next one? Good. Can we do XW? A few of you are saying yes. Does everybody agree with those few? What's the dimensions of W again? 3, 2, right? What's X? 2, 3. Now this time we're looking at 2, 3 first, right? X, W, did they match up? What's the size of my answer? 2 by 2, right? Because it's like this. X is over here, right? These got to match. And then the size of the answer is that, right? All right, go ahead and do it. See how you do.
I don't get that at all.
Sit.
The only part that I get is the part that you just get. Like the size of the table that is made. That's the only part I get.
The 2 by 2 part.
Yeah.
So remember, you're going to do X times W. So you're going to go 4 times what? Plus 7 times.
Maybe 2.
Nope.
Yeah.
And negative 2 times.
-1.
We're going to go this way. All right, we're going this way first. That's first, right?
Yeah.
This way. And then we'll go this way.
So it would be -2 times 5. That's for F. Which we don't refer to.
Okay, so then you're going to go 5. Well, that's for the bottom. Top row, there's going to be 2 numbers, right?
Well, yeah, but like doesn't the F go first? So like what would the -2 do?
This negative 2?
Yeah.
That 2. Remember, you're going to move this way, that way. Then you go this way, that way. That'll be your top 2 up there. Then you're going to go this way, that way, to this one. And you go this way, that way, to that one.
Thank you.
You get it already, John?
Working on it.
Okay, you're starting with this. This is first, right? Right, we're gonna go. How about 4 times this? How about 7 times 1? This one is negative 2. So you gotta go cross, and then I'm gonna go block. No. Remember, X is first in this one. So you look at the X top row first. And the W column. Not there though. Go X first. And yeah, so that's the top left spot. And you're gonna go this one, and second, top right. Never -3. And if these numbers are these would be 1 and 1. What'd you get? That?
Yeah.
And it's supposed to be a 2 by 2, remember? You got a 3 by 2.
What?
You guys agree? All right, these two say this. 15, 14, negative, I'm sorry, go across the road. 15, negative 6, 14, negative 9. You guys all get that?
No.
No? Really? Ooh, there we go. They did it. They are correct. So remember, we're doing X first, right? So you go which way first? Horizontally along the top row. And then the first vertical, first column, right? So 4, 7, negative 2. 4, 7, negative 2, 3, 1, 2. 3, 1, 2. 4, 7, negative 2 again in the second column. Negative 2, 0, negative 1. Then you do this row. 5, 1, negative 1. And then these don't change. You're going 3, 1, 2 again. 3, 1, 2. 5, 1, negative 1. And then 2, negative 2, 0, negative 1. Questions? Get it? Got it? Good? Ready for homework? No.
Yes.
Let me show you something. Get out your calculator. Your graphing calculator. Guess what? Guess what your graphing calculator will do? It'll multiply them for you. You just got to put them in your calculator. All right? So, look at the fourth button down. What's it say above it? Okay, so hit second matrix. You get names, math, and edit. Everybody see that? Okay, so those of you that don't have this calculator, you're going to have to do it the way we just did those two, by hand. Okay. Edit. So I like to hit the left arrow key once to go to edit. Some people hit the right arrow key twice. That's your choice. All right? And we'll just use the first two. We'll always call them A and B. All right? Even though in this problem it's X and W, right? All right, so hit A. What are the dimensions of X? So hit 2, enter, 3, enter. That'll give you a 2 by 3 to push in. All right, and then put 4, 7, 8, 4, enter, 7, enter. It goes across the rows when you put it in. So 4, enter, 7, enter. Negative signs down here at the bottom next to enter. Negative 2, enter. And then it'll go to the next row. 5, enter, 1, enter, negative 1, enter. Any issues getting that far? Everybody there that's got their graphing calculator? Any questions? All right, now, Olivia, you okay?
Yeah.
All right. Now, for some reason, you can't just pop right into the B matrix. You have to get out of this. So here's what you have to hit. Right next to the second button, what's it say above mode? Quit. Go second mode. That gets you out of there. I'll just clear this out. All right, keep going. Now, how do I get back into the matrix? Second matrix. All right, how do I put stuff in? Edit. But now we're going into which one? B. Second, quit, right next to it, second mode. All right, then go second matrix, get back in. Over to edit, that's where I'm at. I just hit number 2 now. It'll give me to the B matrix. What's the dimensions of the B matrix? All right, so 3 enter, 2 enter. Now, put these numbers in. 3 enter, negative 2 enter. 1 enter, 0 enter. 2 enter, negative 1 enter. So it goes across the rows. It'll just go down for you. Any problems? Questions? Okay, so what do I gotta do now? Get out. How do I get out? Second mode, which is quit. All right, so I made A the X and B the W, so I want to go A times B, right? We just did X times W, right? All right, so I go back into matrix. How do I do that? Second inverse button, which is the matrix button. Now, leave it on names, just hit enter. And A pops up. What are we doing with these two matrices? Multiply. Times. How do I get back to matrix? Second matrix. How do I get B to pop up?
Down.
Go down 1 or hit 2. Just hit enter. And it gives you the numbers. Oops. Okay, so we got the same numbers, right? 15 negative 6, 14 negative 9. Okay, so you can use your calculator to do the matrix multiplication. Okay? But I wanted to show you by hand in case something happens to your calculator, or for those of you that don't have.
How do you reset it? Like, even when I turn it off, it doesn't.
No, it won't reset. You'll just have to, when you go back and do a different problem, you'll have to put new dimensions in. If they're the same dimensions, just go back over it. And when you use your arrow key, your right arrow or enter key, it'll move to those numbers and then you can change the numbers. Now, we did, on this back one, we did, what did we get? So that was what? WX. So what should you do in your calculator now? Right. Remember, X was which one that you put in? A. And W was B. So go back in and do B times A. See if we got the right answer. No? Then maybe I did something wrong.
Wait, it was that one?
Yeah, that should be that answer.
Yeah.
That's it.
Alright. I thought you meant to say the same one that we did to like the next
No,
one.
B times A should give you this, if I did it right. I might have made a mistake. Did I?
No, you did it right.
Okay. Okay, so far so good? Questions? Okay, let's see what else we were supposed to go over, but again, was XY possible? No, that wasn't possible, was it?
No.
So this is what? 2 by 3, and what's this? 2 by 2. The 3 and the 2 don't match, right?
No.
Was BC possible?
No.
Yes.
What?
That's a 3 by 2,
Oh,
and this is a 2 by 2, right? The 2's match up, so we could do that one, right?
Yeah.
All right, a square matrix. What do we know about rows and columns? If it's a square matrix, it's what? Equal, right? 2 by 2, 3 by 3, 4 by 4. Okay? Multiplicative identity matrix. Is any square matrix named with the letter I that has all of the entries along the main diagonal equal to 1 and all the other entries equal to 0? Well, why didn't it show? I thought I had a picture of one. All right, I'll give you one. The 2 by 2 square matrix or identity matrix would be 1, 0, 0, 1. That's the main diagonal, top left to bottom right. If it's a 3 by 3, it'd be 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay? That's the identity matrix for multiplication. If I multiply a 2 by 2 by this, or something that's, anything that has 2 columns, I can multiply by this, and I'll get the same answer. I'll get the same matrix back. If I've got something with 3 columns, this has got 3 rows, then I multiply, I'll get the same matrix back. All right? So you can find powers of square matrices. Okay? So that's a square matrix, P cubed. All right? You can't just cube all of those. A lot of kids think that. You have to actually put this in your calculator and then hit caret cubed. All right? So I'll just make it A. So second matrix, edit, A. It's a 2 by 2, right? So I already got the 2 there. 2. All right? And then there's a 4. I already got the 4. I just hit enter. And 0, and 2, and 3. So I go second quit, second matrix, enter, to the third power. So caret raises it to a power, 3. So 64, 0, 74, 27. These two are cubed, but 2 cubed is 8, not 74. Okay? So you need to put it in the calculator. You can do that to square matrices. If it's not a square matrix, you can't raise it to a power. Okay? Because the rows and the columns don't match up. It's not a square matrix. There's your homework. Good job. Those of you that don't have a graphing calculator, I suggest you find one.